Algebra 1, Lesson 10.4. Again, what I mean by that is I did 2 algebra lessons and a pre-calculus lesson back to back to back. And I think for the first time I hadn't double checked all my settings or checked the first recording after doing it. And yeah, my microphone was muted for all 3 of them. So I'm going to redo some of these. Well, eventually all of them, but only a couple of them right now. And yeah, so here we go. So this is lesson 10.4, radical equations. So 10.4, radical equations. And what's going on here is we are solving for x, where x is initially trapped inside of a square root. That's what's going on. And let's see. Basically, it comes down to 3 steps. So step 1, isolate the radical. Another way of putting that is oops, that's supposed to be a t, get the square root by itself on one side of the equation. Now, step 1 may or may not already be done for you. It could be that what you're given is, oh, look, the square root is by itself already on one side of the equation. And the term here, isolate the radical. The radical, again, in this context, we're talking square roots, but a radical can be a cubed root, a fourth root, a fifth root. A square root is basically saying what number times itself would equal the thing inside. Right? So that's why the square root of 64 is 8, because by putting 64 inside of a square root, we're saying what number times itself equals 64, and the answer is 8. If you had a cubed root, it would be what number times itself and then times itself again will equal whatever's inside. Okay, but here, because we're just dealing with square roots, really it could be, isolate the square root would be the same thing as isolate the radical. All right, step 2. Square both sides of the equation. And we do mean the entire side of the equation. So as a little aside here, like if we had, like let's just say we had square root of x equals x plus 3. When you square both sides, the left-hand side just becomes x because the square root of x squared is x. Squaring a square root basically gets rid of the square root. So squaring a square root kind of cancels out the square root and you're just left with whatever's inside. Equals x plus 3 squared. You have to square the whole side. That is not x squared plus 9. That is not just square each individual term. X plus 3 squared is x plus 3 times x plus 3. Okay? X plus 3 squared is x plus 3 times another x plus 3. And that, we should be decently good at this by now, but x squared plus 6x plus 9. Because, x times x is x squared, x times 3 is 3x, 3 times x is another 3x, so you put the two 3x's together, you get 6x, and then 3 times 3 is 9. Okay? All right, so that's that step. And then step 3, solve for x. And a step 4 that sometimes you have to do, check for extraneous solutions. And here's what's going on. Whenever you're going to solve and you end up with an x squared as part of what you're trying to solve to figure out what x is, and you get two different answers, it could be that both answers work, but most likely one answer will work and the other one will not. And the one that does not work is called an extraneous solution. Because of starting with the square root and then squaring both sides, if we reversed that, you would be starting with, something squared, like an x squared, and when you take the square root of both sides, you have to do a plus or minus the square root. But what we're starting with doesn't have a plus and minus square root. It only has one or the other. And that's kind of, we're kind of like solving a quadratic equation in reverse in a sense. Well, we're kind of creating a quadratic equation. That's what we're doing. We're creating a quadratic equation that has two answers, but only one of the answers will work. And so you have to check for extraneous solutions when that's going on, or any other time that you're told to check your answer. Okay? All right. I have 4 examples for us to do, and here we go. So, first one, solve. And we want to solve this. Square root of 7x plus 2 plus 3 equals 7. All right. So step 1, isolate the radical. All right, what do we have to do to get the radical by itself here? We need to subtract 3 from both sides. So I'll show that step here just so that it's really clear what I'm doing at first. But you, in your work, if you don't want to show the minus 3 on both sides, that's fine. You can just jump straight from what you're given there to the square root of 7x plus 2 equals, what do we get now? 4. Okay. All right. Do we have the radical by itself now? Yes, we do. So now we can square both sides. Again, when you square a radical, squaring and the radical cancel each other out, and you're just left with what's inside. So we have 7x plus 2. And when you square 4, you get 16. Let's subtract 2 from both sides. That gives us 7x equals 14. Then we're going to divide both sides by 7, and that gives us x equals 2. Okay? There we go. I didn't show all my steps there, but technically I'm doing minus 2 to get that. And then here I'm doing over 7 and over 7 to get that. But the blue, except for this minus 3, minus 3, minus 3, minus 3, other than that, the blue that I showed here is about the level of work that I was expect to see now. All right, hopefully that makes sense. Let's do another example. This one looks like this. Solve 3 root x minus 5 minus 4 equals 8. So is the radical by itself? No, not yet. And we can treat this radical, this square root of x minus 5, kind of like if you had something like 3y minus 4 equals 8. What would you do first? Well, first you would add 4 to both sides. Add 4, add 4. Then you have this 3y equals 12 now, and then you would divide both sides by 3. It's the same sequence of steps we're dealing with here, but instead of a y, we have a square root with stuff inside of it. Okay? So I'm going to add 4 to both sides first. And again, if you don't want to show that part, that's okay. So that gives us 3 root x minus 5 equals 12. And then I'm going to divide both sides by 3. That's going to give me root x minus 5 equals 4. Now I can square both sides. Squaring the left-hand side frees the x minus 5. Squaring the right-hand side gives me 16. Add 5 to both sides, and I get x equals 21. And that's my answer. Now, if you were asked to check one like this, oops, sorry. I accidentally did a bunch of zooming in there. If you had to check one like this, The rule is the same. You start with the original formula that you were given. So we're saying, does 3 times the square root of 21 minus 5 minus 4, does that equal 8? Now you can't do anything like add 4 to both sides because that equal sign has a question mark over it. In other words, we don't know for sure this is equal, so we can't do stuff that we can usually do to equation. All we can do is simplify one side or the other independently. So let's do some simplifying. 3 times the square root of 21 minus 5 is 16, minus 4. Does that equal 8? Well, the square root of 16 is 4, so 3 times 4 minus 4. Does that equal 8? 3 times 4 is 12. 12 minus 4. Does that equal 8? And 12 minus 4 is 8. So cool, 8 does equal 8. It checks out. Okay, next example. Solve. And we're doing square root of x minus 6 equals x. Okay, step 1. Isolate the radical. And in this case, it's already done for us. So step 1 is already done. So step 2, square both sides. X minus 6 equals x squared. Step 3 now is solve. Okay. Now we're going to have to do a little bit more work to solve this time. Because like last time, if I write the steps, all of this was completing step 1, isolating the radical. This was doing step 2, squaring both sides, and we didn't even have to show a separate step for the solving, because all we had to do was add 5 to both sides. Okay? We're going to have to do a little bit more work for solving on this one, though. And the reason why is because we have this x squared. So this is a quadratic equation. So we can use a quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Or I would recommend starting out with seeing what factoring you could do. Is there a greatest common factor that you can pull out? And if not, is it 3 chunks, and with an x squared, can you just do regular factoring equals 0, and then take each factor and make it equal to 0? So, well, let's see. Let's move the x squared over to the other side. That's going to make it a negative x squared plus x minus 6 equals 0. Now, that's a good step in the right direction. I like equals 0. Now, the question is, can I factor the left-hand side? Well, I don't like this negative x squared hanging out, so I'm going to reverse the sign of each chunk, and that's going to give me a positive x squared minus x plus 6 equals 0. Okay? All right. Now I like to check again first to see if I can factor this. Now I have a 1x squared. And when I have a 1x squared, I can just check to see if there are two numbers that I can multiply. I just noticed, let's see, this is not going to come out very pretty. Because I wrote something down wrong. It was supposed to be an x plus 6. Okay, so I'd make that an x plus 6. So then here when I reverse the sign of it, oh no, x plus 6. So here when I reverse the sign of everything, this became an negative x minus 6. Okay, so note here I have a 1x squared. And when it's a 1x squared, I can look for two numbers that multiply to be this negative 6 and that add to be this negative 1, or negative 1x to be negative 1. It's just a coefficient there that we care about. So let's see what we can do. So I have a negative 6. So I'm looking for two numbers that multiply to be negative 6 and add to be negative 1, and that's negative 3 and 2. Now again, when it's a 1x squared, that's where you can go straight into factoring this, like x minus 3 times x plus 2 equals 0. That negative 3 is there, and that 2 is that plus 2. So now that I have a factor times a factor equals 0, I can make each factor equal to 0. So that gives me x minus 3 equals 0, or x plus 2 equals 0. Here that means x equals 3 or x equals negative 2. This is one where we have to check for extraneous solutions because we were solving a quadratic equation. And so let's check our solutions and let's see what happens. So first let's check x equals 3. So when x equals 3, so I'm going to say let x equals 3. I need to go back to my original equation. Is it true that the square root of x plus 6, or sorry, not x plus 6, 3 plus 6, 3 plus 6, does that equal 3? Well, this is the square root of 9. Does the square root of 9 equal 3? And square root of 9 is 3, so yep, 3 equals 3. Okay, that one checks out. Now let's check our other answer, x equals negative 2. So let x equal negative 2. So now I'm saying this is the square root of negative 2 plus 6. Does that equal negative 2? Well, let's see. This is square root of 4. Does that equal negative 2? Well, the square root of 4 is 2, and 2 does not equal negative 2. Now again, if what we started with here was a plus or minus, and this would be plus or minus, this would be plus or minus, in which case the negative 2 equals negative 2, but we don't have that plus or minus going on. And so this is our extraneous solution, which means this is our only actual answer. All right? And one more example. Solve, what are we solving here? Square root of x plus 1 equals x minus 1. Well, so once again, step 1 is already done for us because the radical is already by itself on that side of the equation. So now we need to square both sides. So when I square the left-hand side, the radical goes away, and I'm just left with x plus 1. But when I square the right-hand side, I have to square the entire side. So that's the whole x minus 1 is being squared. Now if I show what's going on, I still have x plus 1. Well, x minus 1 squared is the same thing as x minus 1 times another x minus 1. Okay. Now we can FOIL that. X times x, that's x squared. X times negative 1 is minus x. Negative 1 times x is minus another x. Negative 1 times negative 1 is plus 1. Okay, I guess I'll go ahead and move everything to the left-hand side, but so when I take that x squared, throw it to the left-hand side, I get negative x squared. I have negative 2x on the right-hand side, so throw that over and I get plus 2x, but then I still have this plus x going on there. I guess if I kind of do some, that became that, right? And then these two became that. And then, yeah, I can add another color here. So that was yellow. Let me go green here. That stayed as that, right? But then check it out. When I do this one here, that becomes a minus 1, and I still have this plus 1 hanging out, equals 0. Sorry if that was a little too much. That's not the way that I did it the first time. The first time I took the x plus 1 and I subtracted x from both sides, and then I subtracted 1 from both sides, and I moved everything to the right-hand side. But I don't know, I felt like moving it to the left-hand side this time, but There's more stuff to move, and it was probably a little bit tougher to track with. Hopefully the colors helped a little bit. Well, all right, so let's simplify. So I have a negative x squared plus 3x equals 0, because minus 1 and plus 1, they cancel each other out. Now, I don't like dealing with the negative x squared, so I'm going to reverse the sign of everything and say positive x squared minus 3x equals a negative 0, which is still just 0. So now, what you should always check for first is there a greatest common factor you can factor out? And there is. Both of these terms have an x in common, so I can factor out an x. That leaves me with x squared over x is x. Negative 3x over x is minus 3 equals 0. Cool. Now I have factored equals 0, so I can take each factor, set equal to 0. So I have x equals 0 or x minus 3 equals 0. So here is supposedly an answer. We'll see. And then here I get x equals 3. This one is supposedly an answer. We just have to see. One of these is probably extraneous. So you have to go back to our original, and let's check these. Okay, so first let's let x equal 0, and we're going to plug that into our original formula. Square root of 0 plus 1, does that equal 0 minus 1? Well, this is the square root of 1, and does that equal negative 1? Well, the square root of 1 is 1, because what number times itself equals 1? 1. So we have 1, and 1 does not equal negative 1. So this is our extraneous. Now let's check our other one. Let's because it is possible that neither answer works. That can happen. Let us let x equals 3. Okay, how about square root of 3 plus 1? Does that equal 3 minus 1? Well, this is the square root of 4. Oops, question mark. Does that equal 2? Well, square root of 4 is 2. 2 equals 2. So it checks out. So this is our answer. Okay, so there you go. I lay out for you in the homework which problems you have to check and which ones you don't. I think there are like 5 of them that I ask you to check, 5 of the 12. And other than that, yeah, hope it goes well. As always, let me know if you have questions or contact me if you want to check some of your answers. And I will see you next time.